Hey guys, this is Coach Kaiser, and you're watching this to learn about dichotomous keys. Your goals for today are that you can write a taxonomic scientific name correctly, and that you can use a dichotomous key in order to classify or to name an organism. Taxonomic classification. It's just a classifying system used to group organisms based on their characteristics. There are levels of taxonomic classification that you should recognize from 6th grade. The broadest is the domain, and then we go kingdom, phylum, class, order, genus, and then species is the most specific. So this picture will just help to remind you that domain is the widest, so it's the broadest, and species is the smallest, so it's the most specific. So binomial nomenclature. So they use taxonomic classification in order to come up with a naming system, which includes actually the genus and the species from the taxonomic classification levels. This was developed from the ideas of Carl Linnaeus. So some examples of binomial nomenclature or scientific names for organisms would be Felis rufus, which is the scientific name of a bobcat, or Homo sapiens, which is the name of people. So why would we use Homo sapiens rather than just using people? Well, not everybody in the world speaks English, so in order for us to communicate in a universal language around the world, we have this scientific binomial nomenclature so that people can understand what organisms you're talking about. So we're speaking the same language. So how would you write a scientific name? So you got to make sure you always capitalize the first letter of the genus, and then the species is always written in lowercase. So there are now 3 options. You can underline it, so have Homo sapiens. Again, the H is the genus, so it's capitalized, and everything else is lowercase. You can italicize it, which is kind of a slant or a cursive way of writing it. If you were going to handwrite it, you can italicize on the computer. So Homo sapiens is kind of slanted. Again, the H for the genus is capitalized. Or you could abbreviate the genus. So I just have H, and then I write out the species of sapiens. Dichotomous keys. So a dichotomous key, so here's a few examples. It's just a tool that consists of a series of yes/no questions based on characteristics that you see of an organism. So let's practice using a dichotomous key. So this is a simple one I made up using a shoe. So we're going to use this key to figure out the name of this shoe. So we always start with question number 1. And so I'm going to read, and I've got 2 options. So one answer is going to be yes, and one answer will be no. And I always follow the yeses. This shoe does not cover the toe completely, or this shoe covers the toe completely. So I'm looking at this shoe and where the toe would be. So it covers the toe completely, so I'm going to move to question number 3. So I completely ignore question 2 because my yes says to go to question 3. So here we are at question 3. This shoe covers the ankle, or this shoe does not cover the ankle. This shoe would come up over the ankle, and so we have arrived at the scientific name, which is Shoe Kaiser. Let's try one more using the same key but a different shoe. Still starting with question number 1. This shoe does not cover the toes completely, or this shoe covers the toes completely. So the toes would be right here, so the toes would be uncovered. So we're going to move on to question number 2. So here we are. We got 2 options now. This shoe has a heel, or this shoe is flat. This shoe is flat, so we have arrived at the name, which is shoe deal. I don't care about question number 3 because I've already figured out the name, which is shoe deal. Alright, so now we're going to look at some common characteristics of leaves, because in science class, when we're going to use dichotomous keys, we're going to use them to identify leaves or insects. So we have to be familiar with the common characteristics of leaves. So this is a simple leaf. It just means it's a single leaf. This leaf is a compound leaf. It has multiple leaflets. So these are called leaflets. So now these leaflets are arranged in certain patterns. They can be alternated from side to side. They can be in pairs and on opposite sides. or they might be in a bunch that's around the center, or also called whortled. Some other common leaf characteristics. This one is a heart shape. If you look at the edge, it's also smooth. Sometimes it's called entire. This one is lobed, kind of like an earlobe. This one has waves. This one is an oval or an egg shape. It is, the edges of it are also toothed, or sometimes called serrated, so it's very sharp or rough. This leaf is narrow. This leaf has a bristle tip, so it's got a point that comes off the end. So these next two leaves would be more for coniferous trees. So this one is more like scale leaves, or more like a fish scales. And this one is a needle-like. And it's also in a cluster because it's coming from the same point, and this one is actually in a cluster of 5 needles. So let's practice a dichotomous key using a leaf. So we're going to use this leaf over here on the right, and here is our dichotomous key. And we always start with question number 1. So here are our options. If the edge of the leaf has no teeth, waves, or lobes, or if the edge of the leaf has teeth, waves, or lobes. So no teeth, waves, or yes. No or yes. And I'm going to say yes, it does have teeth, waves, or lobes. So we are going to question number 3. So we're going to skip down to question number 3. If the leaf edge is toothed, or is it waved or lobed? So remembering our characteristics, is this more toothed or lobed? It is more toothed. It's more rough. And so the name of this is a Lombardy poplar. Let's try one more leaf. So we're using a different leaf, but the same dichotomous key. We're always going to start with question number 1. So looking at this one, we're looking at the edge. Does it have teeth, waves, or lobe? So it looks pretty smooth. So we're going to go with no teeth, waves, or lobe. So we're going to go to question number 2. So here are our options. If the leaf has a single bristle at its tip, so does it have any kind of extension on the end? I'm going to go with no bristle. So we're going to skip down to question number 4. Is the leaf heart-shaped or not heart-shaped? Yes, it looks pretty heart-shaped. And it also does have veins branching from the base. So we have the base, and then we have branches of veins coming out. So we have discovered the name of this leaf. It actually comes from a redbud tree. Alright, some important things you needed to know from this video. You should know the order or the levels of taxonomic classification. I might ask for you to list them complex to simple, which means you should tell me domain, kingdom, phylum, class, order, genus, species. Or I might ask you to tell me the levels from simple to most complex, which means you would start with species and end with domain. You should also know how to recognize or how to properly write a scientific name. So you always need to include the genus and the species. You capitalize the first letter in the genus, and all the other letters are lowercase. So now you can either underline, italicize, or abbreviate. You should also know why we even use scientific names. We use names just so we can communicate around the world, so we can speak a universal language that everyone understands. And now you should also know how to use a dichotomous key. So we're going to practice that now. If you have any questions on how to use a dichotomous key, check with a buddy, and then if you still need help, raise your hand and let your teacher know.